Today we'll see the source code file, like what exactly will contains in the Python source code file. So for understanding the source code file, so you basically have to understand the syntax. There are four things like in the source code. There are tokens like every Python source code contains tokens. In these tokens, there are four things like keywords, identifiers, literals, and operators. Whatever the source code file you open, you basically see only the four things. Like there is one more thing, operators. So you open any kind of source file, Python source file. It consists of only these things, like keywords, identifiers, literals, and operators. Other than this, nothing will be there in the Python file, source file. So we have to go deep into all of this. So today we'll mostly discuss about keywords. You go to this one. These are the keywords. We'll group these keywords. There are 35 of them totally. So we'll discuss each group. Like these are in alphabetical order. So you have to remember all of these one. So if you are a Python programmer, you have to remember this one. The reason why we have to remember this is, so I said identifiers. So identifiers will discuss later after this topic keywords. So for creating an identifier, yesterday we have discussed what are the rules for the identifiers. You should not use the reserved words, like keywords or reserved words are same. So for creating an identifier, you should not use any of these keyword names. So you can extend, like you can use underscore, you can use some name, but you cannot directly use the keyword name itself as a variable name, which is identifier. So we'll start with keywords. So yesterday we have written in interpreter. Today I'll try to write in Python. So if you want to check what all keywords are present in Python, there is one module, keywords.kw list. You can print this one. If you print this one, it will show all the keywords present in this Python version. You see, we'll count how many of them are there. Using length method, we can count. There should be 35. See, 35 keywords are there. Now we'll start grouping them. Like initially, if you take branching, there are three keywords: if, else if, and else. So this is used for basically checking the conditions and branching. So for example, if you take score, so we want to divide them by uh, like which class, like first class or second class, those kind of things. So for example, his score is 60. And how do we write the condition for grouping them, like dividing them into which class the score falls in? So we basically check for the score. The score is greater than 60, greater than or equal to 60, he or she will fall into first class. So if you want to check one more condition, you have to use else if. This is basically else if, but the keyword is elif. And for elif, we have to write one more condition. Score is greater than or equal to 1550. So then we have to check one more also for third class. 30, 35 we can say. So if nothing is, if none of this condition is going to match, then it will fall into the else statement. So if you see the score is 60 plus printed first class, so it falls under 50, should be second class. Now it is third class, and then finally it will fail. If it is less than 35, it is fail. So for these kind of things, the condition branching keywords are used. I hope you understand about the branching and condition statements. So in the keywords, the next group is like loops. If you take loops, there are two loops, like for loop and while loop. So loops basically works on the iterable types mostly. And if you take, like for example, try and range, we would like to print square of first 10 numbers. So we can do like this. Basically printed the square of the first 10 numbers. So and if you'd like to add sum of all the first square of first 10 numbers, and you basically have to add this one. And you print at the end. This is basically built-in type, so nothing will happen, but I'm adding underscore. There are some built-in identifiers. It is better to not use them. That's why I did some. So this is basically the sum of first 10 numbers, square and sum of the first 10 numbers. Now we'll use the while loop. So if we take x equal to 0, and basically for while also, for while you need a condition. If x is less than 10, if this condition is true, then it will go and execute the statements inside this one. If it fails, the while loop ends. While x less than 10. In the for loop, we are not controlling the iteration type, but here we have to control the iteration also. So here we have to control the x value also, like we have to increment the x value ourselves. So sorry, this is not right. This is x. So if you see like same previous example, so we are squaring first 10 elements, first 10 integers. And if you follow same thing like sum of the first 10 integers, basically need to add it. So finally we have to print it at the end. Same thing as printed. So we have seen branching and looping statements. And now we'll see how to define a function. So for defining a function, there are three keywords like which are used in function definition and return type, def and return. All these three are related to function definition. Like we use def to define a function, and if the function is returning something, we have to use the return to return a value or some sequence or something. And the yield is mostly used in writing a generator functions. This we will discuss later point of time, like when we are discussing about the generators. Currently we'll discuss these two things. So to write a new function, you have to give the name of the function, which is an identifier. So for example, if you say square, and it takes one parameter, like if the function has any input parameters, you have to define here. And what these functions do, will return something. Initially we'll print square of the number. So for using this one, we just call square, and it is taking one input parameter. Where to pass that one. So 10 square is 100. 10 tens 100. So it printed the output. So what if this function has to return a value? You simply replace with return, and you have to print the returned value. Here you have to use the print. This method will return a value like the square of this number. So this is about functions, like how you define a function and what are the input parameters and the return type. So for example, if you have to import a modules, like someone has written some module and you have to import a module, there are some keywords for using those modules like import, from, and as. So if you say there is one module called system module, to import that one, you have to use import sys. And there are some functions in that, some methods, and it has some classes also, but we'll simply use some methods in that one. We call this dot or v. These are the arguments list which was sent to this file, like whatever key.py file. When we try to run this one, I'll try to pass some arguments. So if you see, this is a list of arguments passed through the command line. But for but the first argument will be the program name itself, like the source code file itself. The Python will set the source code file itself as the first argument. You see, in this list, the first parameter is like first element in this list is the program name itself, like the source code file itself. You try to give extra arguments, then it will be from 1 and 2. This is the second element and this is the third element, where we can read the arguments passed from for this program using this sysv or args argv. For importing that one, you have to use import.sys. And there is one more import statement. Sorry. From date time, you can use this one also to import statement, import the modules. So now we have imported datetime module, and if you see, there is one function called now, which will print the date, current date and time. So you see this one. And the next keyword list is like we'll see some lambda functions. So lambdas are basically like anonymous functions. Like you if you see the previous function, like we have written square, and we have returned number. So we can write the same function, like we can write this function lambda. So this is the input parameter. Whatever we pass here, number, can assume this as number, and this is the return statement for this function. You can pass this one here directly. So this is the lambda function. Whatever this square is doing, same thing this lambda function is doing. These are the input parameters for this lambda function, and this is the return type. This one line statement is the return type. If there is any one liner, we can replace that one with lambda functions. So how to use this one is like, this one. In call same like previously how we called, no? Can use, this is the reference for this lambda function. We are calling with that reference like a method or a function, and we are passing this parameter, the number. This 10 will go into this number, and the calculation will be done with this statement, and this is the return value of this lambda function. And finally, it will print that lambda, that calculation. Is the square, 10 square is 100. This is about lambda function. Like if you want to write for a cube, so we'll basically write one more time. So this is similar as these two things are similar. This lambda function and whatever this one is doing is similar thing. So for testing, we'll replace it with this cube. So this is the cube of 10. Likewise, there are a lot of keywords. If you take for exception and error handling, there is try, except, finally, and rise. Those are related to exception handling. And assert is there for testing. And there is one thing, like if you see, there are values, special types, true, false, and none. As I said, there are values. Some of them are values in this keyword list. If you see closely, none, true, and false. Where is false? This one. So if you see, all these keywords are starting with not only starting, and they are all with small letters like and, as, assert, break. All these are with small letters. But these three things like false, true, and none, they are looking special. Like they're starting with capital letter, capitalized. Like false is capitalized, true is capitalized, and none is capitalized. The reason why these are capitalized, these are values. These are basically keywords, but these works like a values for the return type. Like for example, if you take a function and if you want to check is it even a number, you basically have to return, sorry. So this will check for the number is even. If it is even, then it will return the true type. Otherwise, it will return false. So you can directly write true here or false. And if the function is not returning anything, you can simply say none. By default, if you are not returning for a function, if you are not returning anything, it will display none only. And see, if you are not returning anything, it is displaying none. True is true. False is false. Now, sorry for checking even numbers. So, okay, leave this one. So you can basically assume these are the values of some type. Like if it is the function is returning true, it is true, and if it is false, it is false, and then none is none. So and if you check this one, there are operators also in this one. Like for comparison operators, there is one thing called as, not as, and one is or and not. This basically like Boolean operations only. Like if two things are similar, if one is true and true, then it will return true. It will return true. This is keyword, and these two are also keyword, but there are special types values. True or true. Any one is true, it will return true. Because the first one is true, it will return true. If both are false only, or will return false. So not is opposite of this one. So these are the operators. So and there are some miscellaneous kind of thing like del is there. Del is for deleting the variables or any item in the list. Like if you say x equal to 10 and print x, and if you delete it, delete x, the x is not available here. Up to here the x is available. From here, from this line onwards, x is not available. So if you try to run this one, try to print x up to here, we have deleted that x variable. From this point of time, x is not available. This is useful for deleting variables, and also it is used in list sequence types. In any sequence, we can remove this one, any element in that either list or dictionary, but it will work only for mutable types. For immutable types, anyway, we cannot change the values of the sequence. It will work only for mutable types. And like this, there is one more miscellaneous also. Like we said, if this function still have not defined anything, so we use this pass. Pass is nothing but like it has no operation. Like if you go for assembly language, there is one operand called no operation. So this is similar kind of thing. This line of code has no effect, but to maintain the indentation of this function, so we are using this one. And some of them are like for asynchronous programming. There are two keywords, async and await. These one are useful for writing code in parallel. Like so, if you write some function which has to run parallelly, like threading kind of thing. So these two keywords are useful for writing parallel code, like asynchronous code. So we'll discuss one example when in the later topics.